Mass calculations in reaction. So we have this balanced chemical equation, this combustion reaction, because we have a carbon-containing compound reacting with oxygen to always form carbon dioxide and water. This is a combustion reaction. According to the U.S. Department of Energy, the world burns approximately 3.7 times 10 to the 15 grams of gasoline. The mass of carbon dioxide emitted into the atmosphere from burning this much gasoline can be found using the combustion reaction stoichiometry. Stoichiometry is another word for mole ratio. So we want to find the amount of carbon dioxide formed from the given amount of gasoline. And the gasoline, even if you can't figure out which it is because the formula wasn't given, you know what O2 is, CO2 and H2O, so octane, C8H18, is your gasoline. So you're given here 3.7 times 10 to the 15th grams of, I'm going to write it in the formula, gasoline. You want grams of carbon dioxide. So the first thing that I like to notice is that I am going from carbon dioxide to C8H18. However, I'm going the other direction actually. I'm going from C8H18 to carbon dioxide. Now, that means I'm going from one compound to another, like A to B. They're not the same. The only way that I can do that is to use mole ratio. So I like to create myself a little map. I say, all right, well, I know that going from CH18 to CO2, I have to use mole ratio. Well, if I want to use mole ratio, I have to be in moles. So I go from moles of gasoline to moles of CO2. That's how I can convert from one to the other, just like we've done in previous problems. However, you're not starting with moles. You're starting with grams of gasoline. So I need to go from grams to moles. When I want to go from grams to moles of the same substance, I use molar mass. So my molar mass will get me to moles. Then I can use my mole ratio to go to moles of carbon dioxide. And then I want grams of carbon dioxide. So then I use the molar mass again. So that's my little 3-step plan. So I start with writing my molar masses on the side. So my molar mass of octane will be 8 carbons plus 18 hydrogens. 8 times 12.01 grams over mole plus 18 times 1.008 grams over mole. And that comes out to be 114.224 grams over mole. And for carbon dioxide, it's around 44.1. So then I just start. Okay, I'm starting with 3.7 times 10 to the 15th grams of C8H18. Now, I know I want to go to carbon dioxide, so I have to use mole ratio. In order to do that, I must be in moles. So I have to use my molar mass to go to moles. If I'm trying to get rid of grams, moles is going to go on the top. And the grams, 114.224, goes on the bottom. Okay. Next, now I use my ratio. What's my ratio? I have a 2 in front of C8H18, a 16 in front of carbon dioxide. So I have 2 moles of gasoline for every 16 moles of carbon dioxide, just looking at the coefficients. Well, if I want carbon dioxide, my 16 moles CO2 will go on the top, and my 2 moles of gasoline will go on the bottom. Now I'm not finished yet because I want grams of carbon dioxide. So I have one more step, and I use now the molar mass of carbon dioxide, and I put grams on the top. So 44.01 grams of CO2 goes on the top. 1 mole CO2 goes on the bottom. And let's check. Grams gasoline goes away, moles gasoline goes away, moles CO2 goes away. You're left with grams of carbon dioxide. When you plug that into the calculator, you will find 1.14 times 10 to the 16th grams of carbon dioxide. So the key here is now we've applied a bunch of different concepts together. Calculating molar mass, converting from grams to moles, mole ratio. What helps me is the first thing that I look at is, okay, I'm going from one compound to another. Here, I was going from gasoline to carbon dioxide. If I determine that much, I always know mole ratio right away. Okay, well, if mole ratio is kind of like my one big step, then I see, okay, am I in moles? Because if I'm in moles, then I just use the ratio like we did with the iron and sulfur example, and I'm done. However, I'm given grams to start, so I need to go to moles first. So therefore, the only conversion from the same substance to go from grams to moles is molar mass. So therefore, I'm like, okay, well, I have to find the molar mass. Well then, I want grams in the end. So then I have to use the molar mass again to get to grams and be finished. Now this can apply to different things as well. You could be given molecules or atoms, for example, to start with or that you want. So you would do the exact same process, but you would use the conversion of Avogadro's number. So it's knowing exactly, all right, I have two different things, I need to use mole ratio. How will I get to moles? Applying those different conversions learned already.